Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honest Geometry class. Today we're going to be talking about two different skills. First one, we're going to wrap up surface area by talking about the surface area of circular solids. And then in 12.4, we're going to go ahead and start on volume. Okay? Just as a little recap, remember that the surface area of any prism, okay, is 2 times base area plus perimeter times height. In other words, the lateral area. Okay? And then the surface area for a pyramid, okay, there were two different equations. One of them involving the slant height and the perimeter and the base. The other one just involving the base and the lateral areas. I think from what we saw on Friday reviewing, I think that is going to be the better of the two formulas for you guys. So it's literally the base area plus the lateral area sum, really. You find the lateral area of each individual side. Now, when the pyramid is a regular pyramid, that means that the base of the pyramid is a regular polygon. You can just find one face area by finding the slant height, find the area, and multiply it by however many sides you have. So for example, let's say you had a pentagonal pyramid, and the pentagon was regular, and you found the base area of that pentagon. Great. Now you have 5 equal lateral triangles, or at least congruent triangles, not necessarily equilateral, but they're all congruent. So you'd find the area of one of those triangles multiplied by 5. When you have a non-regular pyramid, you find the base area, then you find the individual areas of all the triangles that make up that particular polygon, and you add those all up. So even though we're dealing with a lot of different figures, you've only really had to learn 2 formulas. Today, the good news, same formula for cylinders, guys. By the definition of a prism is a 3D figure where you have 2 identical bases, correct? Well, look at what a cylinder is. It's not a prism by definition, because the bases of a cylinder are not polygons, they're circles. So that's where the difference, the nuance comes in. This is not a prism, quote unquote. Because again, by definition, a prism is a 3D figure where you have 2 parallel congruent polygon bases. But in essence, here's my base, here's my base. They're both parallel and congruent. So even though it's not a prism, gentlemen, you can still use the formula 2b plus pH, where the base, big B, okay, is the base area. Just remember that the base area for a circle is pi r squared. That's why you have that there. And then the perimeter times the height. Remember that the perimeter for a circle is the circumference. Okay? That's why for P, you got 2 pi r, because that's your circumference, times, of course, height. Yes, sir, my brother.
So the only difference between a cylinder and a prism is that the bases are, one is a polygon, the other one is...
Correct, sir. The question was, so the difference between a prism and a cylinder is what again? A cylinder is a polyhedron, okay, 3D figure with bases that are circles always. A prism is a polyhedra or a 3D figure where its 2 parallel congruent bases are polygons. Okay? Now, if you remember when we broke down the 3D figure, like for example a box, we broke it down and had two sides, a front, a top, a back, and a base, correct? A bottom. Well, let's go ahead and break up a cylinder as well. I think you'll enjoy this. When you have this original cylinder, if I pop off the tops, those two tops are simply two congruent circles, correct? You guys with me here?
Yep.
Right? Okay. Now, if I were to unroll the cylinder, wouldn't it become a rectangle? Right? Think about it. Go ahead and make a little semi-cylinder with a piece of paper, except you're not going to have any caps to top them off with. When I roll it back out, doesn't it become a rectangle? Okay. The width of the rectangle is my 2 pi r. And my height, of course, is the height from base to base. So this would be my height. Why is this important, Mr. Morrow? Well, sometimes it's good to understand where these formulas are coming from. Why is it that they're doing this? Okay? So I have two bases, hence 2b plus circumference times height. Well, think about it like this, guys. When I had this cylinder all rolled up, wasn't the distance around the circle the same as the distance that formed this cylinder when I wrap it together? Are you guys seeing what I'm saying? Look. Here's a cylinder. Okay? The distance around this cylinder, isn't that the same as the length of this paper? You see it now? Okay? So that's why we have our circumference, that's the length of the paper, times height, the distance from one base to another base. So when you break down a cylinder, it's the top circle, the bottom circle, plus the side, which is really what makes the cylinder. You with me here? Yes, no, maybe, kind of, sort of? Okay, so the good news, there's no new formula for cylinders. Prisms and cylinders have the same exact formula. 2 times base area plus lateral area, which is the perimeter or circumference in this case, times height. Because it's perimeter of the base, which is circumference. Okay? Now a cone. A cone is another kind of circular solid, and a cone is a little bit different. Okay? A cone, the formula is pi rs plus pi r squared. Pi rs times pi r squared. I like my way of doing it better. That s represents slant height. Okay? So the surface area of a cone is pi r squared plus pi r times slant height. So basically, it's the area of the base, that's my pi r squared. My r is the radius. My h is the height, which goes from base to vertex, or apex, or pinnacle, to the top part of the cone. And sh is my slant height. My slant height is the hypotenuse, basically, when I create my radius, my height. My slant height is the hypotenuse, so slant height equals the square root of r squared plus h squared. Where is that coming from, Mr. Morrow? Pythagorean theorem. Thank you. Okay? Literally. So this is another new formula you must remember. So far you've got prism, 5 formulas. No. You've got prism and cylinders, which is 2 base plus lateral area, which is perimeter times height. Now, then you have a pyramid, which is base area plus the sum of all lateral areas. That's 2. And now 3, surface area of a cone, is pi r squared, basically the base area, times basically half the circumference times slant height. Because if 2 pi r is circumference, pi r is half the circumference. Okay. So again, my surface area is pi r squared, which is my base area, plus pi r, which is half the circumference, times slant height. Does everyone see all of the pieces to this puzzle? Because if you don't, that's what I need to make sure that I sharpen up. Sir, my brother. Of course I can. Thank you. What's up, my man? Got it? Yeah, it's the same formula here, guys. I repeated the same formula a couple times here just to make sure I drove home the point. Yes, sir.
Can you explain it again? I don't really get it.
Okay, what don't you get exactly? It's pi r squared, which is the base area,
No, the second part.
plus pi r. Isn't that half the circumference? Circumference is 2 pi r. Half of 2 pi r would be pi r times slant height, which is the hypotenuse when you make a triangle of the height and the radius. Does that make sense? Thank you, sir. Any other questions? Great question, by the way. Thank you. Anything else, boys? All right, let us continue. Give me 1 second, please. Okay, so let us continue. A sphere. It's another formula you guys got to learn, but it's pretty simple. I think after I explain it, it's 4 pi r squared. Now, this one's pretty simple because this is the way I think of it, okay? Pi r squared is the area of a circle, correct? Okay. I'm going to do my best to really try to help you guys understand this. Think of a sphere, which you guys have seen, soccer ball, basketball, volleyball. When you were a kid, the bouncy ball, okay? A football is not a sphere. And I spelled sphere incorrectly. I apologize. Oh no, a football is not a sphere. Okay? A baseball is a sphere, sure. A globe is a sphere. Tennis ball is a sphere. Golf ball is a sphere. Sphere, it's a round object. Now, this sphere is basically made up of the following. A circle in the center, okay? A circle across the diagonal, okay? Another circle across this diagonal, okay? And then a circle down the middle, okay? So it's basically 4 circles that are put together and sent in a rotation. So just remember that a sphere is 4 circles put together and then rotated. So can that make sense? Okay? Okay? Not really, how? Go ahead, sir. Thank you for your honesty. All the radiuses would be the same because you're within the same sphere. Yes, sir. All the radii, yeah. So it's pi r squared, but since it's a sphere, there's 4 circles that make up a sphere, so it's 4 pi r squared. Does that make sense, gentlemen? Okay, so let's get to work. Find the total surface area of each figure. Okay, there's a cylinder, so my surface area equals 2b plus lateral area. In this particular case, it's going to equal 2 times base area, which is pi r squared, which is 25 pi. You can leave it in pi. Plus perimeter. Perimeter of a circle is a circumference. So that's 2 pi r. So that's 10 pi times my height of 6. So that's 50 pi plus 60 pi. That's 110 pi units squared. That's the surface area. That is the area needed to completely wrap up that cylinder. This is what you have to come up with. Let's say if you work, at Pepsi, for example. The cans. Cans are not just generated by, oh, well, let's see if it fits. It's a cylinder. Cans of beans, tuna, vegetables, any canned items. They actually had to find the surface area. They needed to know how much metal or cardboard or plastic do I need to make this figure. So this isn't just stuff that just, oh, it doesn't matter. It matters immensely. Pistons for your car. Pistons are cylinders. Okay? And they need an exact surface area for that as well. B, find the area of this cone. Okay, well, the surface area for a cone, which we just saw, was pi r squared, the base, plus half the circumference, so pi r times my slant height. Okay? In this case, I gave you everything you needed. In this particular case, we got pi r squared, which is 25 pi, plus pi r, which is 5 pi, times my slant height of 6 in this case. So that's 25 pi plus 30 pi, which is 55 pi units squared. Now, just so you understand this, my friends, sometimes I'll give you a height. Say I gave you a height, whatever, I'm just throwing numbers out there, of 8. And let's say I gave you the radius, let's just say it was 6. How would you find the slant height here? Pythagorean, or you could recognize this is a 3, 4, 5 times 2, so my slant height would be 10. Please be careful when I give you this, though. A lot of times, my students, they switch up the formulas. This is my height. This is my slant height. This is what goes into that formula. Okay? So please be very cognizant of that. Be careful. C, I have a sphere here with a radius of 5. Remember, the radii of all the circles that make up a sphere are congruent. So exactly, good job, my brother. This surface area is 4 pi r squared. So my surface area will equal 4 times 25 pi. So my surface area equals 100 pi units squared. Yeah, 25 because 5 squared is 25. Thank you for carrying, sir. Thank you. Does that make sense, my brothers? Wait, okay. Okay. All right. Now, D. D is awesome. I love D. D is actually quite easy. Okay. This up here, guys, it is a hemisphere. Okay? Half of a sphere is called a hemisphere. If you notice, isn't the world, our Earth, made up of a northern and southern hemisphere? The equator is that circle that cuts the Earth in half, pretty much. So in this particular case, exactly along the prime meridian, very good. So for this case, guys, we have two different areas. We have area 1 here, and we have area 2 here. And yes, you got to add them up. Okay? So the first area we'll do in green is for my hemisphere. Now I know that the formula for a sphere is 4 pi r squared. But we're going to divide that by 2 because it's a hemisphere, so it's 2 pi r squared. Now, what is my radii here? That's exactly correct. It's half of the diameter, so it would be 150. What are we looking at? 6,250? No, not 6,000. What's wrong with me? 2,250. That's right. Times 2 is 4,500 pi units squared. Okay, that's the area of this hemisphere. Half the sphere. 45,000? Sorry, they told me 4,500. I'm not using my calculator. Are you sure? 15 times 15 is 225. But then 2 zeros, yes. So 45,000. Thank you, my brother. Thank you. Now, area 2. This is a cone. So area 2 has a surface area of pi r squared plus base perimeter. I'm sorry, not really. Half of it. So pi r times slant height. Okay. Do I know my slant height here? No, we're going to have to use the Pythagorean theorem. We do know that that's 150 though, correct?
Yes.
Okay. So what would this be, you think? This is a 345 times, no, not times 5, but times 50. Right? There's a 345 times 50. So 5 times 50, this would be 250. Now I have everything I need. Pi r squared, so we have, I'm sorry, so yeah, 22,500 pi plus, yes sir? No, that's a great question. My boy asked, is this circle in between part of surface area? No, because it's inside of it. Surface area is the outside. Oh, I'm very proud of you. Great question. So we got 22,500 pi plus pi r, which is 150 pi, times slant height of 250. All right, guys. So using pi, what's 150 times 250? Guys, use your calculators. Come on. 150 times 250 is? Okay, I guess I'm going to have to use my calculator. Okay, so 150 times 250 equals 37,500. So now my total answer, add them together. And you've got 60,000 pi units squared. And that's it. Sir.
This might be a really stupid question, but
No worries. I did add them together.
no.
Oh, I'm sorry. Yes, so at the end, that's the surface area of the cone. So my total surface area, will equal, let's see, what is it? 105,000. Yeah, 105,000 pi units squared. Okay, you were going to ask my brother?
I know you could just assume this on the test, but wouldn't you need to make a right triangle before you use the Pythagorean theorem there?
There is a right triangle. if you think about it, this is a vertical and this is a horizontal. The intersection of a horizontal and a vertical line, they're perpendicular. Yes, sir.
The pi r squared base the cone.
Pi r squared is right here. That's for the base of the cone. Yes, sir.
So that's not part of the surface area.
No, but remember. Okay. Oh, I see what he's saying. You're absolutely right. You're absolutely right. Okay. Wow. You're on fire, kid. This total area here is wrong. Let's think about this. Mr. Morrow is not paying attention. My bad. Okay. The surface area of the cylinder of the hemisphere is what we have there. That's perfect. The surface area of the cone is right here, 60,000 pi units squared. However, when we put them together though, the base here, this base is no longer part of the surface, is it? It's inside. So my total area is really 105,000 pi units squared minus the base of that is shared by both the hemisphere and the cone. So minus 22,500 pi. Right here, buddy. Okay? So then what do I get? So what is it? Yep, 82,500. That's exactly right. Pi units squared. Wow, that was brilliant, dude. I can't believe I almost made such a stupid error. Thank you, son. Yes, sir. Yes, sir. On a test or a quiz, yeah? How do you know that's a hemisphere? Because it's half of a circle? No, 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 no. When you have a situation like this, there are no gaps here in this intersection. So since they both share the same base, that's half of a circle. I will, if it was a quarter, I would tell you, hey, this is a quarter, or whatever it is. But it's going to be a hemisphere unless I tell you differently. Yes, sir. I didn't get 150, and there is no triangle. Half the radius, buddy. It's half the radius, buddy. From here to here is half the radius. Yes, sir. Thank you, sir. Okay, I guess we weren't listening. Okay. Doesn't this hemisphere and this cone, doesn't it share this intersection point right here? Isn't that already inside of the figure? So is that part of the surface? So I found the area of the hemisphere. I found the area of the cone. Surface areas. But now I have to subtract out that center part. Yes, sir. You could have taken it out originally from the formula, yes. Okay? No, thank you, sir. Thank you. Next, volume of prisms and cylinders. Volume is different than surface area. Surface area is how many square units encompass the outside surface. Volume is, definition from chemistry, how much matter inside of a figure. Okay? That's what volume is. And volume is straight up base area times height for both prisms and cylinders. It's literally that easy. Okay? It's literally that easy. So find the volume of the rectangular prism here. Well, you get to decide what the base is. Do you want the base to be this guy here in blue or this guy here in green? Okay, that's fine. So my volume is base area, which is 20 times 5 times the height of 15. So that's 1,500 units cubed. Because now I have 3 dimensions: a height, a width, and a depth, or a thickness. And that's what volume is, literally, for both prisms and cylinders. So it's really not that difficult. Yes, sir. Okay, the question is, would it be a bad idea to say length times width times height? Okay, if we were only dealing with rectangular prisms, then sure, it could be length times width times height. But what happens when I want you to find the volume of, for example, a cylinder? Length times width doesn't work. What if I tell you find the volume of a hexagonal prism? Then you need to find the base area, and that's not going to be length times width. So that's why I don't teach length times width times height. That's only for one particular. That would work for a cube or a rectangular prism. But I don't teach it that way because this can encompass the volume for any prism and any cylinder. Base area times height, literally. Okay, for example, right here, find the volume of this triangular prism. Length times width times height would not work here. First of all, please remember we're talking about a prism, so the triangles here are the bases. Got to remember that right off the bat. Okay? Let's find the height of that base of that triangle. So go ahead, that's 10, that's 10. When I drop an altitude, that becomes 6, that's 6. This looks like to me a 3, 4, 5 times 2. So 8 is the height. And now I can find my volume. Base area, which is base times height, divided by 2, times the height of the figure. Remember that the height of a prism is the distance from one base to the other base. So that would be 15. So that's 6. So that's 48 times 15. And 48 times 15 equals 720 units cubed. Are you guys with me here? Cubed is for volume. As I had just said, because there's a length, a width, and a depth, or a thickness. 3 different measurements. Yes, sir.
Oh my god.
Okay, the question was, why is it that area is squared and volume is cubed? Well, okay. Apparently, my description did not answer the question, so I will re-explain it. When I am looking for just area, whether it's surface area or just the area of a figure, you have 2 dimensions, length times width. So whatever, let's say 2 feet and 3 feet. Area equals length times width, so it's 3 feet times 2 feet, which is 6 feet squared. Do you guys remember from algebra, what do you do to the exponents when you multiply the same base? You add them. So a foot times a foot would be a foot squared. What does that squared represent? That there are two dimensions, a length and a width. Now, when we're talking about 3D figures or polyhedras, now we have three different dimensions. We have a length, a width, and a depth or a height. So we have three different dimensions. So if this is 2 feet, and that's 3 feet, and let's just say that's 4 feet, well, that's 12 times 2, so that's 24 feet cubed. Because a foot times a foot times a foot is a foot cubed. Also, there are three dimensions: length, width, and height. Sometimes that height is known as depth or thickness. Does that make sense, everybody? Does everyone understand why we use squared for area and cubed for volume? Thank you. Okay, let us continue then. Find the volume of this cylinder. Well, very simple. Volume equals base area times height. So this is going to be 9 pi r squared, times the height of 12. So this would equal 108 pi units cubed. That's okay. I make mistakes, dude. We're learning here. It's all good. Thank you, sir. Does that make sense, boys? Okay, now let's find the volume of this right prism. Okay, before we get into this, if I was asking for the surface area, remember that this piece right here would have to be subtracted out because that's not part of the surface. However, here I am simply asking for the volume. So let's find the volume of this guy here and then add it to the volume of this guy right here. It's that simple. So my volume here would be base area times height. Now, let me go ahead, clean this up a little bit. Okay, let's do the announcements real quick. Okay, so like I said, guys, since we're finding volume, we don't have to worry about taking out this particular area. Okay, we don't have to do that. However, in this case, we have volume. Now, the question is, Mr. Moore, you only gave 2 dimensions. No, I didn't. Even though my drawing is not perfect, I apologize for that. Isn't this distance 10? Isn't this distance 10? So this distance is 10. So volume of my top prism is base times height divided by, base times height times base area, geez Louise, times height. So my base area here, let's call it 2 times 10, which is 20, times height of 5, which gives me 100 units cubed. And then my area of the bottom larger prism is base area, which is 70, times height of 4, which is 280. So my total volume here would be 380 units cubed. Okay? Does that make sense? Now, one thing, guys, and you're not going to be very happy with me here, but unfortunately, that's the way it goes. Back to this guy. Back to this guy real quick. You know what? We did it all wrong. We did it all wrong. Because now that I'm thinking about this, think about what I had said before. If this part right here is not valid, aren't there two bases I should have subtracted from there?
Really? No, because
Yes, really. Because my hemisphere here, let's do the green's hemisphere. My surface area is 4 pi r squared, but of course it's hemi, so it's 2 pi r squared. Okay? You with me here? Right? So my hemisphere is, my radius is 150. We had said that's 22,500. So we had said that this was 45,000 pi, correct? Okay. However, I've got to take out this area here. So this is really minus 22,500 pi. So it's really 22,500 pi. Then the area of the cone, surface area of the cone is pi r squared plus pi r times slant height. We had determined that this was 250, right? Before? Okay. So I have pi r squared, which is again 22,500 pi, plus 150 pi times slant height of 250. But I have to subtract minus, again, another pi r squared. So minus 150 squared pi. Okay? I know you guys want to get out of here, but I had done this completely wrong. The surface area here is the surface area of the hemisphere minus this interior circle. The area of the cone here is the surface area minus the interior circle. Yes, sir.
But if the equation for like a full sphere is 4 pi, I mean, yeah, 4 pi r squared,
Correct, sir.
and divided by 2, it's half.
That's hemisphere, correct?
Subtract the base.
Okay, because the hemisphere will give you this part right here. But is this part right here outside of the surface, or is it within inside? Think of an ice cream cone. That bottom part that's touching the cone part, is that part of our surface? So we had to take away that surface area, and we had to take away from the cone as well. Okay? Practice it. Do your homework. We have a quiz tomorrow. Thank you. Have a great day. Bye-bye. Hope you learned a lot.